They're odds, which means the answers are.
Yeah.
So if you're not getting, it's supposed to be 33 and you're not getting 33, come see me and I would love to look at it and help you get the 33. Okay. So I'd love to help you get there. Okay, so you have some problems tonight you ought to do. And really, if I was telling you the truth, I'm not even doing much of this. I'm really going to stick a lot in this today. In fact, we're going to go straight to that rule. It's actually called the empirical rule. No, there is not. That is a good question, though. Okay, so looking at our notes, we left off on a problem about the uniform distribution. We're going to come back to that now. The good news is that you're going to get most of your points today by just working with your group because I've got an assignment for you shortly hereafter. It is not worth it to me. No, it is not.
When do we turn in our project?
Today is Wednesday.
Oh, I didn't remember us taking that.
Today is Wednesday.
Yes.
I would put it in the bucket.
Well, no.
So before you leave the room, put it in the bucket.
Sorry.
No, that's not a bad question. I didn't even think you say, hey, your project's due today. Kind of forgot it was Wednesday. But, you know,
They should know where it is.
probably so. Well, not really. You should be that responsible. Okay, let's see. I'm going to skip this one. We might have to come back to it later, but for today, I'm so excited to get to normal distribution. I don't even want to talk about the area below that. Yeah, I was so excited. We were talking yesterday about a density curve, and just a reminder, a density curve is really what you and I have been doing to data all along. We've been applying it and making everything beautiful, even if it was supposed to be a hot mess. You and I pretend it looks like that, even if it really looks like that. Okay, and then my area's not really here. Okay, so we also talked about z-scores yesterday. Is it good to have a z-score near 0?
Yes.
There are bad z-scores. What number? Yes, dear?
2.5.
And that's how your group gets a point. 2.5. Positive or negative 2.5 is too big, and we start getting concerned. Okay, and then so today we're going to talk about a normal distribution, which is pretty much where we're going to live here in discrete. Holy bejesus. I know. I'm telling you, I've been in discrete land all day. So, if we apply our density curve, if we have a density curve, that is symmetric and mound shaped. So, yes, sir? Okay, cool.
If we have a z-score within the range, like close to 0, but not quite there, is it possible for it to not be symmetrical, even if it's within the goal z-scores?
You know, life is very rarely perfectly symmetrical. Sometimes we just close our eyes, and when we write it on our test, we would say roughly symmetrical. Like, no, it wasn't quite, like you're saying, what if we have a z-score that's like negative 0.5, and it's really close to 0?
Within the goal z-scores, but still be, like, not symmetrical?
Yes.
Okay.
Yes. Okay, in fact, we're about to apply some specific numbers to what we're looking for in life, even more specific than that 2.5. Okay, so a density curve that's symmetric and mound shaped, and we're going to add something else. It's not just enough that we see this pretty looking bell curve. We also have to prove that the information, the data, follows the empirical rule. Follows the empirical rule. Okay, tomorrow when Jackson comes to class, am I going to expect him to actually remember the word empirical rule, or that phrase? No, but he does need to memorize these 3 numbers, which are also listed below. Some people call it the 68, good grief, Ms. Compton, 68, 95, and 99.7% rule.
Is there a reason it's those specific numbers?
Yes. Okay, so obviously the next question is going to answer Jackson's question of what is this? Why those specific numbers? So let's draw us a normal bell curve. And instead of talking about z-scores, we're actually going to talk about standard deviation today. So let's say this is the mean, but hey, when we calculate z-scores, we use standard deviation anyway. So, okay, so this is the mean, and I'm going to say this is one standard deviation. And this is obviously also one standard deviation, but it's a negative one standard deviation. And then we'll say 2 standard deviations could happen out here. So we're 2 standard deviations away from the mean. And then we are 3 standard deviations away from the mean. Okay, so I'm very excited that Jana and Cody aren't here because they're the 2 that didn't take the test, so I can say testy things now. You're the one who asked me a question yesterday, yes? Yes. Didn't you ask me a question after school about, okay. So there was a problem on the test that was multiple choice, and she tried to make it into something like this. Even though it was supposed to deal with just calculating the standard deviation, she tried to turn it into this and she didn't even know it. So, just so you know, this is kind of along the lines of what you were asking me yesterday. So if we're within 1 standard deviation, and I'm going to go all colorful on you. If we're within 1 standard deviation of the mean, so we're here, 68% of our data, if we're a symmetrical thing, is going to fall within 1 standard deviation of the mean. So let's pretend our mean is 50. That means 68% of our data, and let's say our standard deviation is 5, so 50% of our data is going to fall between 45 and 55. Whatever our mean is, whatever our standard deviation is, 68% of our data, no matter what, if it's symmetrical, 68% of it is going to fall within 1 standard deviation of the mean.
So it's like that question on the test where we had to find out what percent fell on the key fruit.
Yes, it's similar to that. Okay, and then I wrote 2 standard deviations, 2 standard deviations. So if we were to say we were 2 standard deviations away from the mean, so we're somewhere in between here and all the way over to here, that's covering a lot more space, right? So it's a higher percentage. So 95% of our data falls within 2 standard deviations of the mean. No matter what, if our data is symmetrical, then 95% falls within 2 standard deviations of the mean. So if we were still using our fake example down here, we would say 95% of our data is between 40 and 60. And then just to make Jackson even more annoyed with me using too many colors today, if we were to go 3 standard deviations out, so we went 3 this way and 3 that way. My gosh, I went too far over here. My bad. So, my gosh, we've colored in most of it now, right?
Yeah.
I mean, it looks like basically everything but the tiny little bit on the curve, right? Tiny, tiny little bit. So, once we've colored in 3 standard deviations worth, we've actually encompassed 99.7%.
You never get to 100 though, right?
No, because there's 2 little tails. So 3 standard deviations away. So between, with our fake example, between 35 and 65, 99.7% is going to fall in. But darn those have to be rare and over here with their 100% selves or whatever. They're going to fall outside. So 3 standard deviations away, where 99.7% of our information is going to be in there. Okay, so mine looks like a hot mess. I was just going to prove the point of coloring. Really, I have a much prettier, clean example one to show you. So we've got our bell curve. Zoom out. And I'm actually going to give you this. I can't copy it today. Darn copier's broken again. So it's showing you that, and I thought Jackson liked this better because they did dots and stripes and like bigger dots.
I don't. It's
So,
a lot harder to understand.
68% falls within 1 standard deviation, 95% within 2, and then 99.7% of the information is going to fall within 3 standard deviations of the mean. And then what's terribly annoying is that sometimes they might just ask about just this region here. So just from here to here. So it's part of that 68, but it's just half of it. So what percentage would that be?
34.
Okay, and that's how you get a point. They're trying to do what we were doing yesterday, where they fit a density curve to their distribution.
Oh, I see. It's a bar graph that they're putting up.
Yeah, they were, well, it's technically a histogram because the bars are touching. But anyway, they applied their density curve to it. But 68%, if it's standard normal, it's supposed to fall in it. So they could ask what big of a percentage falls within the mean and the first standard deviation, and that would be 34%. And then they could be mean enough to make you subdivide some of the others. So just keep in mind, yes, 68 between the one standard deviation away, but so it's just 34 for one positive standard deviation away and 34 for one negative. They're having questions where you have to remember to divide by 2.
Also,
Yes.
why is there a bottom part? Why is it?
Because they connect to the bottom part of the.
Yeah, I think they were trying to show that even if the data happened the other way around where it was all negative, as long as it follows this curve, as long as it's a standard normal curve, it's still going to follow the same principles. Heck, I don't know. I just
I think
Googled
it
it trying
helps the marking the units. Maybe.
Okay, I was trying to be helpful for Jackson because I was like, colors are not going to help. I needed to find a different pattern one. So I found a different pattern one, and
Now
you're
that I
right.
see the whole thing, it does help.
It kind of helps, but I'm with you. Like the bottom thing at the bottom, maybe not. So I'm giving you this tomorrow. Couldn't copy it today. Darn copy was broken, and I hate standing in line. It is the worst. It is the worst. Okay,
Go
so
back and watch a lot of good videos.
my friend Ms. Asbury is a vegetarian, and she mentions it like somehow it gets brought up. I hope she never watches this. Okay, moving on.
You mentioned her today.
Moving on. So again, if you need to write words, because some of us have just got to apply words, 68, 95%, 99.7%, 68% of the data falls within one standard deviation of the mean. And then if we've got to write it with words, and I'm out of room to write it, but with 95, it would say 2 standard deviations, and with 99.7, it would say 3 standard deviations. So in just a moment, I'm getting you a worksheet, and they'll say, you know, we're wanting 95%. We want to be 95% positive. We've gotten all the data. What range should we use? And you would take the mean, add 2 standard deviations, take the mean, subtract 2 standard deviations, and then you would have your range of values where 95% of the data is going to fall. Words, English.
Okay, I'm confused. How is that where the 95% of that? 95% of data is, but it's like figured.
Yeah, it's actually just the middle. So it's just the middle, but it's the large chunk because it's just not the 2 tails. And heck, we still don't encompass the tails.
It's not just
Yeah.
those 2
Oh, okay,
sections.
got it.
Oh, you would think the middle would just be 50 because it's so, look at how much of that, like, compared to, like, how high that is compared to how low down here. This middle bit, you would, I get what you would guess
If you
that.
drew a line down the middle and was only 9, that would be 50%.
Yes. And you can have a point for that. See, this point thing might work out really well for you. You can end up with over, because you know I'm not going to let me, of course, table not have any points just because they're quiet. So eventually I'm going to say everybody add so many points. And eventually that means y'all are going to be over for the day. That would be our goal. Yeah. Okay. Alright. Okay, so we've got 2 examples for what we need, and then I've got some problems for you to do with your group. And I swear you don't have to finish it for homework, because let's face it, you already have a textbook assignment you ought to be doing for homework. Okay.
This is right at me.
I know. Just to,
That
that must be it. That must be it.
I hate this chair. I hate this chair.
The chair hates you.
Yeah, I think it really does.
It's not a very good chair. That's right.
Isn't that right?
Luis, you can't decide when I was
Okay, sorry.
It's an evil chair.
Okay, so 99.5. 99.7. So, okay. So I was going to work the next 2 examples, but to be honest, they're not that easy. So we're going to save those. We're going to let you practice with the easy ones, and then we'll come to them. Because I do love you somewhat. But before I pretend like I for real love you, let me show you something, and you won't be obliged to value your finger up. So Jackson's given this information. He's told the mean score. He's told the standard deviation. My God, he just has to figure out, like, is it 68% who would score less than 87? Okay, but the one that confused me at first when I read it was 2.5% scored less than what value? Where the crap did they get 2.5%?
It's half of the left.
How?
Only from the outside of the
Yeah, it's the 95.
95, there was 5% left, right? And they took the 5% and they divided it by 2 and got 2.5. Okay, I'm glad y'all are that smart because I was having a moment. I don't care if you work with your group. I don't care if you join another group because your group's quiet. I just need things done.
Do we get points for that?
You can have a point for that. How many points
Louise
do you have?
gets it too.
Thanks, Jackson.
Louise can have a point for being alive. And you know what? Ashley's table can have a point too because this is just getting out of hand.
I think I did
We're done.
You're just like handing out points like Oprah.
That's pretty much how
You
point
get
you're
you
doing.
get